So we're going to talk about, excuse me, we're going to talk about open source tools for Agile development. So let's figure out what we're going to do here. So I'm going to talk about, obviously, tools, but let's talk a little bit about why we want to talk about tools. So what is Agile development? What is about agility? Agile development is about developing relevant working software. If the software you're developing is not relevant, we might as well go home, right? At the end of the day, do people care to use it? And the second thing is, you don't want to be delivering documents, right? You want to deliver software. I'm not saying you shouldn't deliver documents, but don't only deliver documents and go home, right? And you want to deliver software that actually works. But the question is this: how do you know it's relevant? How do you know it's working? Now, it's interesting that you've heard the term capturing requirements, haven't you? Now, think about the choice of words. What do you capture normally? You capture something that runs away, right? So that means the requirements run away, and you're trying to capture it. So it's extremely difficult to capture requirements because it's very fluid. And, pragmatic programmers talk about this. They say that software follows this Eisenberg principle. The minute you show the software to the user, they don't want that anymore. They want something else. So the one way to make sure we deliver software that actually meets the customer's expectations is to get this constant feedback. So in fact, I would emphasize that if your approach is to develop what the customers wanted, you will fail. You want to develop what the customers still want. And that is not an easy thing to do, right? You want to constantly keep up with it. So you want to be able to develop the software, constantly check in your code. You want to be able to get that feedback, develop in these increments. And yes, you can demo the application, but I don't recommend just demoing your application. If I demo and do a dog and pony show, it's like, wow, that's really nice. But the minute I give the software to you and put you in front of the computer and say, go use it, imagine the type of questions you end up asking as a user. So one of the best ways to make sure that your application is relevant and useful and meet the customer's expectation is to have them exercise your application very quickly. Don't wait for it to mature too often. In fact, they actually help you to mature the application as it's being developed. And you want to be able to deliver this in increments as the application is being developed. So one of the things is to create this relevant working software. It's pretty hard business to do. So the feedback is very essential. Now, there are two kinds of feedback. One kind of feedback is whether the expectations, you as the programmer, you as the one who is writing the code, is it meeting the expectations? But also, equally, if not more important, is the second level of feedback. Is the application meeting your customer's expectations? The outer one is the circle of relevance, right? If it doesn't meet the customer's expectations, no point doing it. Now, of course, you could say, but if that is the most important thing is to deliver what the customers are expecting, why not just focus on the outer circle? Well, the problem is if we only focus on the outer circle, this is what happens. You develop this application, you go to them and say, hey, here's the application. What do? They look at it. But do the customers ever look at your application and say, wow, thank you. This is what exactly I wanted, right? They never say that. They say, interesting, but, right? And then they want you to change these things. Well, what do? You say, thank you, that's great feedback, and you go back and modify it. What happens when you modify it, right? So there's this little toy in some of these, toy places. What they have is something called a whack-a-mole. A whack-a-mole is, the kids are given this wooden handle, and there's a little mole that pops up, and the kid hits that mole. What happens when the kid hits the mole? One pops up over there, right? And the kids love playing this whack-a-mole because you don't know which mole is going to pop up, and you keep hitting these moles. And then these kids grow up and they become programmers, and guess what they do? Right? You end up creating whack-a-mole systems. Your customer says, this area is not good, go fix it. You go fix that area, and that other area is broken, right? So you're not able to sustain your development because there's no way to know whether the application is continuing to meet your expectations. That is why this inner circle of feedback is extremely critical. Without this inner circle of feedback, the outer circle collapses very quickly, and you can't really sustain this development process. So it's very important for you to be able to sustain the development. So as much as the outer circle is so important, the inner circle is even more important for the sustaining of the outer circle. So the question is, how do we keep up with all these things? Well, the first one of the values in the Agile Manifesto says that individual interaction is more important than process and tools. In fact, I would go to the extent of saying that a fool with a tool is a dangerous fool, right? So you cannot just give tools to people and expect that they will succeed. But having said that, if you find above average to good developers, and then you can give them tools, then they are more productive. So tools can help us a great deal if used rightly to get this feedback and maintain the health of the application. So the question is, what kind of tools can we use? So one of the first things in Agile development that you may want to do to address this inner circle is unit testing tools. So a unit testing tool can help you to automate the test. It used to be the days when I would say, I don't need this stuff because I write code, I write tests. The real difference is you don't want to be manually testing your code for the output. It gets tiring, it's error prone, and we don't do it as often. But if you can have a tool that runs and tells you whether the code is working and continuing to work as you expect, then that is a great advantage. That's where the unit testing tools provide automation for you. So one of the things, and it takes a certain amount of effort, but it's not an insurance, it's not an expense, it is an investment. Because you're investing your time into this, and then it pays off when you start refactoring and evolving your application. It's not the question of if you refactor, right? It's not a question of if your application changes. It's a question of when your application changes, right? Because it is certain that it's going to change and you need to be able to accommodate it. So the question is, what can we do with unit testing tools? There are quite a few tools available in the market to do this. Let's take a look at an example here. So what I'm going to do here is to show you a very quick example. It's a very trivial example, but still nevertheless it illustrates a few points here. So what I have here is a little game to do a guessing game. So I have a little guesser class in place. So this guesser basically is going to allow me to guess a certain a certain number, and here's the code to do the guessing, right? Not a whole lot of code, right? But I want to know if this guessing game is doing what I expect it to do. So what have I done over here? So I have a few test cases for it. So notice there is the test guesser extends test case because I'm using JUnit for running this in this case. And then the test guesser has a little setup where I'm creating the guesser. Then notice the different cases. Hey, well, here's another thing this illustrates. Sometimes we give up testing because we don't know how to test the code. If a guessing game generates random number, how do you test something that generates random number, right? So that's when you sit down and say, how do I approach this testing? If you notice what I've done here, that's okay, let it generate a random number, but I'm going to feed him a number on this side and then see if it's coming out on the other side with the proper guess. So you need, just like everything else, right? We have a lot of skills, but we take the time to learn it, right? And you can wade through the traffic really quick in your bicycle, but you did have to take the time to practice and get better at it. Same thing with unit testing as well. You need to learn a technique to do that. So if you notice over here, I have created the guesser object, and I'm asking him if the target has been set properly. I'm asking him what the guess is given this particular target. I'm guessing a lower number, I'm guessing a higher number, and seeing how it works and so on. And of course, when I write these tests, you can see that actually there appears to be a lot more test code than the real code itself in this particular case, which is not too unusual, by the way. But at this point, I can actually execute it, exercise it. This can be automated. I don't have to think when I modify the code. I can just run this and see if things still work. And that kind of feedback helps us a great deal to make sure that the application is continuing to meet our expectations as time goes on. And that is basically what this is providing. As you can see, there's this green bar in the bottom. Yeah, so the green bar indicates that all the tests have been passing. So JUnit and NUnit for .NET, similarly there are other tools. There's in today's world, almost any language that you care to use has a unit testing framework. So it's important to take a look at what those are and start using it. Any questions or comments before we move on from this little example? Okay, so that's great. We can decide to do unit testing, but we could have other problems, right? What kind of problems could we have? There are certain things that can stop us from performing unit tests. I'm going to ask for a volunteer from this side of the room. Anybody want to help me? Come on, be brave. Who wants to help me here? Come on over. So he's going to help me out to understand how to unit test this. Can we get him a mic, please? There you go. See, we're ready for you. Hey, what's your name?
Hey, I am Chandra.
Chandra, welcome. So we got Chandra here. All right, Chandra. So I've got a method that I have this habit of writing a lot of code. I like coding. So I just wrote a method that's 1,000 lines long. What do you think?
It's really disappointed.
Why is that?
I don't like 1,000 lines of code.
Well, you don't like it, but why?
It's very hectic to go on every line of code to check what actually the functionality is going.
Bingo, right? This is called a ball of mud, right? When you have a ball of mud that's huge, there is absolutely no way you can write a test on it. Imagine the number of variations it's going to take, all the path it's going to go through, and how do you possibly sit there and write a test? So when somebody tells you this code is not testable, you translate to English, it sounds like this code sucks, right? So exactly what it is, a poor design is very difficult to test. Now if my code, so let's say I wrote a small code, but it is talking to some heavy system over there, doing credit card processing, right? Or calls into a function that's going to take 7 hours to return. What do you think of that?
It depends on the functionality, how it works.
Right, but how do I test my code's functionality when it has such dependencies, right? My code is going to take so long to run, I cannot test it, right? So testing is also hard when your code has so many of these dependencies, right? So what should I do to make my code testable? Do you have any ideas?
Reduce the dependency.
Bingo, right? So you want to reduce the dependency, so lower the coupling, and also when the code becomes smaller, what happens to it? It becomes more cohesive. Hey, wait a minute, last time I checked, higher cohesion and lower coupling are good design principles, right? Okay, now you said take away the dependency. How do we take away this dependency, right? So let's take a look at an example here, or at least the problem over here that we have. So if you look at the code, well, actually, I'll come back to this. So if you look at the code on the top, notice what happens. This code on the top is pretty simple, right? It has no dependency. The red one, that's easy to test. But if you look at the one on the left side, that's very difficult to test, which is what you had said, right? It's got too many dependencies, you cannot test it. What do you do? So here's the way to think about it. Who's your favorite actor? There's a reason I called you here, right? So who's your favorite actor?
I go for Mahesh Babu.
Okay, I don't even know, so I'm out of touch with this world. So Mahesh is a great actor. It's got to be a great actor because here's a fan of him, right? So of course, if he's a great actor, I want to make a movie with him. I'm going to ask him to come to stage at 3 o'clock so we can make the movie. That's great. What I got to set up the stage properly for his height and weight and everything. So I'm going to ask him to come here at 9 in the morning so we can help him set it up. What do you think of that idea?
Good enough?
Good enough, but it's going to cost me money, right? It's going to go through the roof. That's too expensive. So what do? I'm going to ask him to come at 3 o'clock. But I'm going to go walk on the streets of Bangalore and find a guy about the size and height of Mahesh. Go to him and say, hey, Mahesh. And the guy's like,
the details of Mahesh in Bangalore.
Well, I know, but I'm going to walk to the streets and call one guy as Mahesh, right? This guy is not Mahesh, obviously, right? Of course. Otherwise, I have to pay again to see him, right? So I go to this guy and say, hey, Mahesh, and this guy turns out like, what, did you call me? And it's like, yeah, I thought you were Mahesh. The guy has melted, right? I was like, really? Yeah, could you do me a favor? Would you come and stand on the stage for the rest of the day? We'll give you Coke and burger, and we will also let you see Mahesh when he comes in, right? What are we talking about here? We're talking about a mock object, right? The mock object is not really as good as the real object, obviously. If it is, my expense still goes to the roof, right? But this guy is not really good, good or, good enough, but bring in a mock object. So that is exactly what we're going to do. So take this dependency of this object that we have here. So rather than depending on the real object, we're going to depend on a mock object. So how do we deal with this? So you first of all create this mock object, and you say, hey, mock object, I'm going to teach you certain calls, and you're going to simply reciprocate these methods for me. And when it happens, you simply reply back. And so rather than depending on the real object, we're going to depend on this mock object. So what's the big deal about this? The code that I mentioned, Chandra, which is going to take 7 hours, is not going to take 7 hours anymore, right? Because I call into the mock, and the mock immediately, bam, replies back the response, so I can test my logic very easily, right? So that is exactly what a mock object is for. Let's take a look at an example. There are several tools available to do this. Here is just one example of a tool that you can use for mock objects. So there are tools like EasyMock, JMock, RhinoMock, DynaMock. Put the word mock in front or after any other word, you have a framework, right? So you got a lot of these different mock object frameworks. And how do you use one of them? I'm going to just show you one example here of how you could use EasyMock, right? So let's go to the example here. Where am I? So let's go to the guessing game. Let's say I want to keep track of the score for the guessing game, right? So if I go to the score of the guessing game, if I know how to type that, there we go. Go to the test directory, and oh, where am I? Over there. Finally, I'll get there. Okay, this is good enough for me. So here is a little example of a test case that I'm using with a mock object. When the tool comes up, I'll be able to show it to you. Okay, so what am I going to do? First of all, I'm going to create a mock, but I don't want to spend our time creating a class for the mock. This is where the frameworks are very helpful. So I'm going to go to Easy Mock and say, hey, Easy Mock, give me a mock object, please. So notice I have an interface, and I say create mock. As you can see on line number 12, I say create mock for me. Bam, it gives me a mock object. At this time, this mock object is like a baby. It's innocent, doesn't know anything, right? If you look at line number 14, I'm creating a score store. My score store is the guy who keeps track of the score, which needs to talk to a database, what have you, behind the scene, right? So notice I'm saying on line number 15, I say expect a call to the repository's get play count, and then in that case, return a 0. So I'm coaching this mock object with all these dependencies, right? And then on line number 23, I'm saying, that's it, you're done with the coaching, go. Now it starts interacting with the real code in the case of a unit testing. So if you look at the line number 24, when I call the update method, it is going to interact with the mock object internally. But the mock, instead of doing the real work, talking to database or web service or what have you, is going to return back a response. So what is that going to do to my unit testing, Chandra?
It will reduce the complexity, and as well it will give a broader picture about the functionality.
That's absolutely right, and it also makes my testing really fast. Exactly right. What happens if my test is slow? Nobody wants to run it, right? So this makes testing quite possible. This greatly influences the design. You seem to know all the right answers. Thank you so much for your help.
Thanks.
Yeah. So that is basically an example of how you can use some of these mock object techniques to improve on your testability. So that is awesome way to enable unit testing on your projects. Now I'm going to talk a little bit at this time to talk about how do you measure not only the behavior of the code, but also what yet another one more important thing, which is performance. When you write a unit test, you want to write 3 types of unit tests. You want to talk about positive test, is it doing what I'm expecting to do? Negative test, is it misbehaving? What does it do when I ask to do something not expected? And the third type of test is an exception test. Is it throwing the right kind of exceptions? But sometimes what happens is you try to measure, you try to refactor a code, but in the process you may have lost a certain performance. Let's say you're writing a piece of code and it requires extensive amount of work to get a certain performance, and in refactoring somebody modifies the code. Yes, the code may be elegant, but it doesn't perform as much anymore. What do you do about it? This is where you can use tools like JUnitPerf. So what JUnitPerf does is, it not only checks if the code is doing the right thing, it also makes sure that the code is performing as you expect. I'm not recommending you do this for everything in your application. You want to do this where it actually makes sense. Let me give you an example real quick here. Let's say I want to write a method, public void, test some algorithm, whatever that is. So let's say test algorithm. And algorithm test is simply going to say, oh, let's say, assert equals, right? And then I'm going to say guesser dot algorithm, right? So I'm just calling that one. And what do I expect him to return? Well, let's pick a number that he's going to return in this particular case. So I want him to return, let's say, a number 6. So I wanted the guesser to be returning that particular value in the call to the algorithm. Now, obviously, this algorithm is going to take some time to execute, right? So it's the long he's returning. Let's say he's returning 6. He's being a good citizen, right? Obviously, a lot of things could go behind the scene. But I'm going to put a little thread.sleep to indicate that there is a bit of a computation that's happening right there as well. So basically, in this case, notice the method is going to take a little longer. Of course, I put a little silly sleep method there. The intent is not to put a sleep, right? This is doing some computation, which is going to take you some time. The requirement is that this better be fast, right? You cannot have this to be very slow in your application. Now, what I'm going to do is, over here, I am actually asking him to verify that this method is exactly working as I expect it to work. And when we run the test, we want to make sure it comes back as a green. Life is still good, right? But however, what happens in this particular case is I want to ask him to perform a performance test. So notice what I'm going to do here is I'm going to create a test suite over here. But I'm going to do something else a little differently. I'm creating what's called a timed test, right? So the timed test is going to be a test of the time, and I'm going to say test guesser, the one I wrote over there. But to him, I'm going to give an allowance of 200 milliseconds, and I'm going to tell him, don't wait any longer than 200 milliseconds, right? Now, this is obviously needs to be finished very quickly, and this is going to be test algorithm that I want to execute. So let's take this example for just a second. So I created a timed test in this particular case. Let's go ahead and put it into a timed test. And I'm going to go to the suite and add the test that I just created, which is the timed test right here, right? So basically, we have just added that particular suite. Let's go ahead and run this and see what it does. So if I execute this, it's going to run all the tests that I already had in place before. And then in addition to that, it is also going to go run, if I know how to type that is, we're going to run the new test that I added also in this case, right? So basically, let's go ahead and run that again and see what it does. And you can see all the tests passed. Now let's assume that I'm refactoring this code, doing some work with it. So I go to the guesser one nice day, in the name of refactoring or other things or evolutionary code, whatever that could be, let's say I modify this code. And as a result of this modification, let's say it's going to take a little longer than I had expected it to take, right? Now I have, even though the algorithm is returning the right result, it is taking longer to execute, longer to respond back, and that is not a good thing, isn't it? So I execute the code, and let's see what happens. You can see the red bar right there saying, aha, even though your code produced the right result, you exceeded the allowance of time that was given for you to finish. I'm not suggesting you write performance tests for everything you do, but in areas where you do have to care about performance, you could use things like JUnit that can do that for you and get, Naresh, go ahead.
I'm not too sure how you derive at a number for that performance. And you could be setting false expectations.
Oh, absolutely. Like every other test we could write.
Running on a developer machine, which is very different.
Absolutely. All that said, correct, you're absolutely right. So that's why you have a tolerance level, and this is only used in extreme case of criticality, right? So it's not that that's why you would do this for everything you do. And also, there is that is a good news and a bad news also. The bad news is, yes, like you said, but the good news is you can say this cannot be performed any worse than this. Right? It doesn't, I mean, to give you an example, I have seen applications where it works really well on one machine, you deploy it somewhere else, it really does abysmally bad, right? So remember, this is not just run on the developer's machine. This is run using cruise control or what have you. So you're making sure that it runs consistently in all these machines and giving that performance so you can actually use it to your advantage. But you're absolutely right. You got to use it with the right perspective, but used correctly, this can be a great advantage. It could be based on every other possibility, right? That's domain specific, that's application specific, that's common sense could be involved in it. So I'm looking at the tools more than, why would you use it? How do you do it? That depends on the application. In some cases, there are, non-functional requirements given to us, right? Where they say, well, the response time should not be fill the number, right? Again, I'm not saying that's the right number or wrong number, but when you arrive at those numbers, that could be a reason where you bring them in. It depends. There could be a place where there are certain applications where the number is extremely critical, right? A missile attack, I don't want a trend. I have a life to live with, right? So there could be a very criticality where there's a certain level of tolerance and responsiveness may be needed. It really depends on the application. It also comes to a point where you could set up a certain example scenario and say, hey, does this degrade linearly? Does it degrade exponentially? That could be a great concern for algorithms. You could use that for that also. This can also be used not only for a time test, you can also use this for a load test, and you can say, go ahead and simulate this across several different threads and tell me what kind of performance you get from this. You could do that also. So those are some of the things you could do with these kinds of time tests. I'm going to get rid of that from here just to show you that you can use some of these techniques and tools to get your work done. So we looked at the performance testing. Again, like I said, you could also do load testing with these if it makes sense. Okay, that's all great, but what about this quality of the code, right? If I'm writing this code, how do I know that the design is fairly good? Again, this is just a tool. Don't take this to the, to the extreme and say, I will follow these numbers. Robert Martin has done a fairly good job of creating a certain way to observe the dependencies of classes and how abstract things are and so on. So basically in this case, you can study the dependency and look at the coupling and see if you can lower the coupling because that leads to a bit more stability. If your class contains more abstractness, meaning you have interfaces in your package, that gives you a bit more stability as well. So again, you can go back and read about these a little bit more if you're interested in, but you can take a look at some of these ways to measure these dependencies. So if you look at all the interfaces in your package compared to the number of classes you have, that gives you this abstractness in your class. Similarly, you can look at the fan out and fan in. So the number of dependencies coming into your package and the number of dependencies that go out of your package, and you can observe these things and say, well, this is basically based on these numbers, I can arrive at a certain indication of the stability. So again, ignoring all the math that may go behind this, you can start studying how this is going to look, and you can start planning, predicting a little bit about the quality of the code in this way. Please. That's what we're going to talk about. So yeah, absolutely. So why don't you come on and help me? Yeah. So what we're going to do here is to measure that. So the question is, how do you measure this dependency, right? For doing that, all that you have to do is count all the number of classes, number of dependent classes, and do a little math, right? So that's what we're going to ask him to do. I'm going to give him a pencil and paper, and he's going to count all of them. What do you think of that idea? You want to do that?
No.
He says, no, take a hike, right? That's why we hire an intern from the college, right? No. That's what we need a tool for, right? That's exactly what we have here is a tool called JDepend, right? So JDepend, hey, what's your name, by the way?
Raja.
Can you help, Raja?
Kaja.
Kaja, okay. So what we're going to do is have a tool that's going to help us do that, right? So, oops. So we're going to use a tool to do that. What's the tool? Such a tool is called JDepend. There's also NDepend, right? There's a cousin for the .NET side of things. So what does JDepend do? So it goes and does a quick analysis. So what can you do in Java? Can you go find out if my class depends on other classes in Java? Is there a way to do that?
Using Eclipse, I can find it.
I'm more at the compiled code level. If I give you a binary, is there a way to do that? Like a bytecode. Is there a concept in Java that can help me do that? What's that? Not even to that extent. You could do that, but simply reflection comes in, right? You could even query this. You don't even have to go to that syntax tree. So you could even use reflection and kind of query, right? So that's exactly what this JDepend tool does. It simply smells the code, not a perfect solution, right? Because certain dependencies are too difficult to find. That's what it does. Similarly, it determines whether a class is an interface and so on, and determines these kinds of values. So once it arrives at this, there's a value called d prime. I can't go into the math right here, but he's promised to study all of that and write about it, right? So we're going to look at the d prime value and do an analysis and say, hey, you know what? Your d prime value is way too high. If it tends towards a 1, that's not a good thing in this application. If it tends towards a 0, then you're lying, right? That's too idealistic. So you want to be at, between about a 0 and a 0.2 or so is a good value. So how do I do that? So let's take a look at an example. We have a little code here that I wrote and then executed it. So let's just make sure things are still working before I go run that and see what the dependency value is going to come back with. So if I execute this code into JDepend, here's how it's going to look like. Oh, let's close this here. This is what I want. So let's go here to... so I'm going to run this right here. So here's the classes I have. So I'm going to run JDepend. How do I do that? So Java, and I'm going to specify the class path and so on. So where's my JDepend stuff here? Let's see if I have it here. No, I don't have it here. Okay. So Java minus, let's say, class path. And I'm going to go look for where I have local lib JDepend. Hey, there it is. So let's get the jar. Okay, I've got the jar file. Similarly, I'm going to also look for user local lib and JUnit where I have. So you kind of know what I'm really doing. There's no magic happening behind the scene. So I'm going to run JDepend JDepend, and I'm going to ask him to do an analysis of this code that I have. Actually, a swing UI. So let's say swing UI, and I'm going to ask him to run through my classes. So which is the class I'm going to specify here? It should be in the classes directory, I think. Let's see if that's going to work. If not, we'll figure out. Swing UI dot. I forgot the API. We'll find out. So right there, I ran it through the classes, and it's hard to see, so I'll make this a little bit bigger. Yeah, that's the best I can do, I think. So if you notice over here, it is telling me a value. It's telling me my dependencies, right? So isn't that cool?
Yeah.
Right? So you don't have to do the work manually. It tells you that here's the coupling you have, here's the abstract classes you have, and then it finally tells you the value of D. Of course, it's very idealistic. I'm lying here. It's 0. In reality, it's going to be different. If you look at the values below, you can see the values are kind of 0 and 1 and so on. We won't go into the detail, but you can take a look at it. Of course, there's an Eclipse plugin for this as well, so you could run the Eclipse plugin. That way, when you're modifying the code, you can get a feedback. Now, here's the problem, though. This is all nice to have, but if I tell you, here is a tool, and then every time you compile your code, go run it, what do you think is going to happen in general?
It will take a lot of time.
It may take a lot of time. People may forget it, right? So you want to automate it, right? The automation is extremely important. If you don't automate it, you forget to do it, and suddenly one day you realize you didn't run it for a while, you run it, and you don't like the result. What do? Keep it quiet, don't run it anymore, right? So it's continuous. You want to continuously keep doing it, right? So what do you do about it? Why not make this as part of your continuous execution of your test? It's not a unit test, but you can just include that as like it's a unit test. So look at what I'm going to do over here. So what I'm going to do here is to go to the test code that I have here, where I wrote the test guesser earlier, if I know how to bring that. So here's my test guesser. And what I'm going to do in the test guesser is, at the very bottom, I'm going to add another test. And the test that I'm going to add here is test dependency, right? Or test design, how about that? Now, obviously, you don't want to be dogmatic about it, right? You want to give a level, kind of a region of margin and say this is what I would like it to be. So what do? New jdepend dot jdepend. So I'm creating an object of this jdepend class that I want to use, right? So basically, I'm going to be creating for, let's say, org dot. Where's that? Okay, so jdepend. No, okay. What am I going to use here? Let's go up here and see. So I'm going to go ahead and import. Oops. Something is wrong here. Let's make him happy. What does he want? Okay. So right there is my jdepend framework.j. It's already there, so I just need to create an object to jdepend. Okay, so basically I'm going to say new jdepend. So I created an object of jdepend, so let's go ahead and put it to a variable called jdepend. Now I'm going to say jdepend dot, and I'm going to ask him to add a directory. Let's just add the current directory to him, right? So that's good enough for now. And then the next thing I'm going to do is ask him to analyze the classes in the current directory, right? So what I did earlier by running the tool manually, right? I'm just running it here automated. Isn't that cool?
That's fantastic.
So what I'm going to do now is to say, now that it's analyzed it, I'm going to say jdepend, and I'm going to ask him to give me a package. So let's say get package, and the package I want to get is my own package right here, right? Because I want to measure the quality of my own code. That's what I'm trying to get here. So let's put it into the package, and then I'm going to say assert equals, right? Oops. Assert equals, and I'm going to say 0, comma, package dot, and then I'm going to say distance. Now, Kaja, question for you. Remember what your numerical analysis teacher told you? He said, never take a decimal and compare it directly to a 0, right? Why is that?
Because the non-decimal points is used.
Yeah, it won't be really accurate, right? So what do you compare it to then?
Integer.
No. Little delta. Right? So you say, here's the number, and compare it to a little delta, right? So you got to give an allowance, right? So I'm going to say 0.2. So between 0 and 0.2, because I don't want it to be exactly 0, but I'm going to give an allowance, right? There's a little delta, right? So if it's within this delta, I'm quite happy with it. Let's just execute this code and see what he does. If he comes back with the green bar, that would tell us that the code executed properly and the design is within our expectations. Now what I'm going to do is just to prove that this is actually working and we're not just smoking here, let's just make sure it's actually doing the job. So I'm going to be extremely aggressive. That's not a good idea, right? It's too much expectation. But just to show you, notice how the test is failing, right? So that is telling you that the dependency, the d prime value was not in the range. Just to show it to you. Now, what's the advantage of doing it something like this? Once you put this as an automated build, as you start checking in code, as you start running your code, as you're evolving your application, it keeps an eye on the quality of the design, right? One fine morning, you'll get a build fail. You go take a look at it. It says, okay, all your code compiled, all the tests passed, but your design sucks, right? So that's the feedback you can take and then modify and evolve your code, and that is something that you could do. So what do you think?
Yeah, it's great actually.
So this is something you can use constantly. Go ahead, please. The question is there an automated tool to generate these tests? Yes, and don't use them, right? The reason is one of the benefits of writing these tests is it can influence the design of your code, right? So a lot of times... Oh, you mean a tool to write this code that you wrote? There's a tool called copy and paste, right? And just copy it and paste it. That's it. Yeah. So that is basically what can do is to just simply run this, and you can get these metric in your application. So that is basically what it's doing. Okay, so we know how to value the design. That's great. But please. Not at all, because we practice evolutionary design. That's why, right? If a design was done once and you never go back and look at it, right? So if somebody tells you that he designed the software and he never changed the design after that, what he's telling you politely is that his project got canceled, right? So it is impossible to design the system once like that. That's why it's an evolutionary design, and you want to keep an eye on it constantly.
So while you designed the class to build code the rest of the functionality, you tested it at a much earlier phase than when you do the unit test.
This is how I design. Design is coding, coding is design. We'll take it offline, right? That is a much more deeper concept we need to talk about, right? It is extremely, there's absolutely no way to verify the design. I can show you all the pretty pictures in the world, and if you ask me to improve it, I'll bring it back in color, right? But how do you know it's right? How do you know it works? Running the test is the way to verify the design. But if you want more, we can talk about it offline. Okay, so that is basically, you've been great help, Kaja. Thank you very much, appreciate it. So that is where we can use these tools to go get these kind of feedback. What about, writing a few unit tests and saying, hey, we are done. Now imagine this for a minute. You write code, but then you realize that there's part of the system that never got touched, never got tested. What's wrong with that code? You know, the code that you write, if you compiled it and you produced a bytecode, but you never ran it, and about 8 months after it goes into production, one fine morning the user enters a certain data, and the control flow goes through that particular logic and wakes up that code. And the code wakes up and says, wow, the guy who wrote me never ever called me. And do you think what it's going to do? It's going to be like a kid kept in captive, right? It misbehaves. It's emotionally deprived, right? You don't want to do that to poor code. If you want a code to behave, you look at the code like a kid and say, you're cute. What a nice kid. That's kind of beautiful that you did, right? And you want to do that, you want to emotionally meet the needs of this code, then it becomes a nice grown-up citizen in the community, right? And so don't write code and leave it for that to misbehave one day. Exercise the code, right? You want to constantly exercise it. If you have a code that you never exercise, that's a code to be removed, not a code to be released, right? So, but how do you know how much of your code is actually being exercised? And that is exactly where a code coverage tool can be extremely useful. And there are several tools available for you like jcover, Emma, and Cobertura, and so on. And depending on the language, there are other tools also available to you. Let me show you an example here as to how you can do it. But of course, the question is, how would this work? How am I going to use this in my own application? That's the question, right? So what I'm going to do here is to show you a very quick example of doing this. So in this particular case, application that I don't care about. Okay, so in this particular case, what I'm going to do here is to run this particular tool. Let's bring up a command prompt and play with it. So here's what I'm going to do. What I'm going to do is to ask him to instrument this code. In other words, he is going to go through every line of code and watch for what is executed, what's not being executed. So this is going to basically instrument the code. So I'm going to run cobertura and say, hey, here's the binaries, the bytecode instrumented. Once, it instruments it, I'm going to run the instrumented code. And after I run the instrumented code, I'm going to ask him to go produce a report, and he's going to tell me what code has been touched and what code has not been touched at all. So how do I do that? So what I'm going to do here is to run the cobertura first of all. So I basically have cobertura running here. So I'm going to simply say run cobertura. If I know where I am, we will get there. So run cobertura. So what does run cobertura do? Again, let me iterate. You're going to instrument the code. Let's take baby steps and see what it does. So notice in this particular directory, I don't have much else. Especially, I don't have any serialization file. Just leave it there for a minute. So I'm going to run cobertura. So I say go on, and he's instrumenting the code. Done. Now, if you notice over here, there's a serialization file sitting in there, right? But also, in addition to this, what he has done, he has created an instrumented directory. Within the instrumented directory, if you notice, he's got a bunch of classes. But if you also notice, in the classes directory, he also has a bunch of classes. Do you notice the pattern over there? They're exactly the same. Well, kind of exactly the same. The one in the classes directory have been picked up, and you have dependency injected into them, right? You have injected the counters into them, and you have displayed this into the instrumented directory. Am I making sense so far? If not, ask me a question, I'll repeat it, right? So you took the bytecode, you instrumented the bytecode, and the instrumented bytecode is in the instrumented directory. The non-instrumented bytecode is still where it is. Now, if I want to run Java program, but I want the instrumented code to be used and not the original code, if it's instrumented, what should I do? Just make sure the instrumented directory is in the class path ahead of the other file, right? That's exactly what I'm going to do. So what I'm going to do now is to go run my test case right here, as you would expect. I'm a lazy guy, so I wrote that as a script. It's running my test. That one was failing. We need to go back and fix and find out where it's failing. And because of JDepend, I can fix that. So I'll come back and fix that in a second. Once it is done, I'm going to create a report so I can take a look at the report itself and find out what's going on with it. So let's go back and take a look at what it produced for us. Thank you. So basically what I'm going to do here is to go look at this code. Notice it created a reports directory. If I go to the reports directory and look at the index.html, it can tell us a certain coverage numbers. Let's make that a little bit bigger for us to see. If you notice this is a result from cobertura, and I go click on this particular package, and within this package I have guesser. Hey, look at that, that's 100% code coverage. This is my lucky day, right? But life is not that easy all the time, so let's go back and mess this up and see how that's going to look. So let me go back to this code for a second. I'm going to get rid of this JDepend stuff because I don't want to be changing my script to add this dependency for now in this example. So get rid of that for a second. So that's gone, poof. Execute this code. But I'm going to do something else before I go further. I'm going to go back to my guesser for a second. In my guesser, I'm going to do something like this. I'm going to go here and say, if my guess value is greater than, let's say, 200, this is a penalty for a stupid user, right? So I'm going to say number of attempts that I take is plus equals, let's say, 200, right? So I just drop this code right here. What do you think of that idea? The code will be executed, maybe, maybe not. There's no test for this code, right? There's no test for this code. That's the sin, right? I'll leave it like that. Let's see what happens. So now I go back here and execute this code. All my tests are still passing, right? Because I didn't break any of them. Okay, let's leave it there for a minute. So let's go back here to this over here, and let's see what I'm going to do. Let's close that one. I don't care right now about this. So I'm going to ask him to run this again. So right there, I'm asking him to instrument it and run cobertura. He runs through instruments the code. I'm asking him to execute this. Hey, notice all my unit tests passed this time. Great. Then I'm going to go ask him to display the results for me. And what does it tell me? So let's go back here, and I'm going to say open the report index.html. Did you notice that, right? If you notice in this case, if you go look at this, hey, this is still lying at me. Why didn't he go back and tell me? Oh, actually, that was a wrong result over there. That's interesting. Did I have a guess value greater than 200? Maybe I did. I don't know. But you can see the count number saying, but there's also something else it's saying, right? It says, hey, look, there is this line number that you have. It has a counter of the number of times these have been called in your application, right? So it says, look, this particular line here has been called 24 times. It's been called 34 times. What you're really looking for is things that have been called 0 times, right? So if something has been called 0 times, and again, I can tweak this to the point where I can show you 0, but we're not going to learn anything more, so I won't waste the time doing it. So basically, in this case, it's going to show you, well, if it's a 0, that means this particular path was never taken. That's a good reason to go back and write the test, right? Now, what does the code coverage tell us? If a code coverage is very low, is that a good or a bad thing? That's bad, right? Because that means part of the code has never been tested, right? Again, when I say code coverage, I'm not just saying coverage through unit tests. Take unit tests, integration tests, functional tests, manual tests, everything put together. Tell me your code coverage, right? It's got to be fairly high. Now, yes. No, it's instrumented code. Once it's instrumented, you can run through any of them. No. It looks for you running the code. It doesn't know anything about unit tests. It's ignorant of unit tests. It simply sits there and says, aha, you ran me, you ran me. So you run through anything you want to run, right? Then you collect all this data. Now the question is, if the coverage is high, the code quality is really good. True or false? False. It's like the cholesterol number, right? I know that's disappointing. You have a high cholesterol, that's bad. Low cholesterol doesn't mean you're healthy, right? Same way, it's the reverse of this, right? Higher number is not necessarily a good thing overall, but a bad number is certainly a bad thing to keep in mind. Okay, so we saw how to run all of that. That's good news. So Kobayashi gives us, and other tools give us, a coverage number. So that is good so far. Now, here is a question. If I have written a coverage, is it quite possible that I have a fairly good coverage, but still my tests don't do a good job? Is that possible? In covering all kinds of different possibilities, right? So I could come through an if statement, but I may not have considered all the branches, all the boundaries. It will not be caught in the code coverage, right? Because I'm still going through that path, but I've not exercised all different combination or possibility of values, right? If you say if I'm less than 7 but greater than 20, well, I may have tested for less than 7, but I may not have tested for greater than 20, right? So that's going to be a problem. So I need a volunteer from here who can help me. Who's going to help me? Nobody brave here? Man, look at that. Who's going to help me here? Thank you. Wow, there's one brave person here. I was getting worried. Naresh will say, I'll come and help you. I don't want him to help me. If you start writing test on test, we already are not writing tests. And then you tell me that you're going to write test on test, you will throw me off the stage, right? Get this guy out of the city, right? It's crazy. But we're going to write test on test, but not quite writing unit test on test, but we're going to test. How do we test our test? So we're going to use a tool. It's called the mutating test. How does this work? So I've got a piece of code here. Let's say you are writing tests for me, right? If I modify the code in a way that it's not good, what is your test supposed to do for me? Okay, so you've written, oh, there you go, here's your mic for you. Now it's going to work. You have written test against my code. I went, and we're pair programming, so it's not that, two different people, but I'm modifying this code, and I made some mistake. What do I expect your test to do for me? Fail, right? You want your test to fail, then you know that your test is good. So how do I know your test is bad? If I make a change, and if your test doesn't fail. Ta-da. That's exactly what this tool called Jester does. So Jester is a mutating test. So what Jester does is, it takes my code and modifies it. It literally takes my source code and modifies it, right, in memory. So don't be worried about hard drive, So it changes the code, compiles the code, and runs the test you wrote. If you don't catch the problem, it says, aha, I found a test that did not, find this problem. So this is a test on the test itself. Now there's one thing I recommend. So if you're taking a course in school, what is a good passing grade you would be happy with on a 1 to 100 or 0 to 100?
Well, I'd be happy with the just pass grade, probably 35. I'll be more than happy.
Oh, she is like me. I actually usually get a 30 and negotiate with the teacher. Hey, 35 please, right? But these days I tell my kids, okay, if your kid is asking this question, what would you say? Or if your brother or sister, little brother or sister, what?
100.
Thank you. 100. That's how I should ask questions, right? Never ask how you would do it, how you'd want other people. Because we always want other people with higher standards than ourselves. Thank you, Gayatri. I learned something today. Okay, so what we're going to do here is to say we want 100. But anything 100, we're going to be crestfallen, right? So you want to sit down before you run Jester, because it does come and tell you really bad scores. Don't show it to this teacher, right? But you want this to be a fairly good number that you're getting. So I'm going to run Jester. So basically what I'm going to do here is to go and run Jester. So Java minus class path in this case, to bring in, so user local lib Jester, and then jester.lib, jar rather. So I'm also going to need, unit testing tool, local. So there's no magic here. I'm just doing this from command line here. So local lib junit and junit jar. And I also need my source directory. I also need my classes directory. Then I'm going to say jester.test, tester, right? So jester.test tester. I'm saying, hey, go test my test. And then I'm going to ask him to run my junit. So test runner, and then I'm going to ask him to use the source directory where the stuff is located. So what he's doing at this point is supposed to run if things were set properly here. Oh, what's he complaining? Didn't work. Thank you. Why didn't it work? Exit value 255. Couldn't do this. Default configuration value. Change exception couldn't run test. What's he saying? I can't realize what he's saying here. Okay. Let me make sure I gave him the correct set of things that he's interested in. So let's look at what my command says here. So I have the tester. I think I gave him all the things he's expecting. Maybe I've made a mistake in the path. Source unit. That looks reasonable. I don't know what mistake I'm making. I'm in the right place. Let me make sure. Yeah, I am. Okay, so basically, let's go back and revisit this. Java minus class path. Anybody finds a bug? Error? You say this should be classes and not class? This is a picky audience. Are you happy now? Okay. So execute that. And, well, still not. It gave me more errors. It was better earlier. Yeah. So I compiled the code, right? So classes is the directory where I have the stuff. Agile Developer, test runner. So I'm not sure what's going on. Jester.test runner. Okay. So, and that's exactly what I have here if my eyes tell me what I have here. Come on, Gayatri, help me here. What am I doing wrong? This is some other directory where I had the stuff, so don't look at the path here. So source classes is the class path. Then I'm calling Jester tester, and then I'm specifying the runner, and then the source itself. Is that what I'm saying here too? The class path. Is there wrong with the class path? What's wrong with the class path? Yeah, I did. Right there's the source, right? It's right here. So I don't know. Okay, so what this is supposed to do is to go back and examine these. And what it'll do when this runs is to give us a log file and a report file. So if you notice, it's going to produce a report. Let's look at if there's anything at all in this from any of the runs I had before. I'm not sure. So no, it did not. So this XML file is going to tell us, and I'm running out of time, otherwise I would run into this. So basically it's going to tell us a score. So if a test survives a mutation, it is going to tell us that it found an error. So play with Jester. Obviously, I'm making a mistake here. So what does Jester do? It tells us that there's a problem with the code because it modified the code, but no test caught the problem. That is called the test did not survive. There's a problem in the code. And it actually pinpoints to what change it actually made. And then, again, don't take that as the begin and end all. It's an indication as to areas where you can improve and write some code. So that's basically what a gesture does. Let's look at a couple of small details. Yes, please.
In your experience, how useful this tool has been? Can you give a specific example?
If you actually, the answer is, how does this really help? Can you give an example? There are times when this would come and tell me that I'm forgetting a certain test, and the thing is, wow, I didn't even think about that, right? More than that, if you go to the Gestures website, there is actually discussions by Ken Beck and Robert Martin, both of them saying, whoa, I thought I'm writing really, really good tests, and this tool actually pointed out things I had never thought about. So that's kind of the aha moment that you see. When you start doing this, there are times when you realize that there are, kind of a certain test area that you never thought. There are, however, having said that, sometimes you get a false positive. That's why don't just follow it blindly, right? It's just an indication. Sometimes it's just false positive and you just want to ignore it and move on. Well, mostly noise level is too high for a lot of things. That is why I go into starting to build this into smaller pieces. Then I don't have to overwhelm myself with a large area, right? So by splitting into smaller chunks, run this on a smaller units of code rather than larger units of code. Then it becomes, anytime I get too many things breaking at one time, I can't handle it. So divide and conquer that. Keep the code dry. There are tools like PMD that will show you detection of copy and paste errors. This is also going to be useful for finding other kinds of problems as well in the code. Findbugs is another tool that does code analysis, and this will tell you if there's any problem in the code level itself, you can find it. And thanks for your help, Gayatri, appreciate it. And so beyond unit testing, there is also things like fit. Naresh talked about this quite a bit extensively. You can talk about using fit and fitness. You can also talk about using tools like, in the case of BDD, you can use tools like ECB and so on. And I've been thinking about this for a while, and the way that I'm understanding this is I'm going to look at unit testing to address my inner circle. I'm going to use the BDD and ECB and all these other type of testing tools for the outer circle of relevance, and that could be a real nice way to use it in our application. So to summarize, I would say, Andy and I recommend that you do this continuously and not episodic. We talk about this in the practice of Agile Developer. And we also talk about this in terms of, if you accumulate these, it becomes very difficult to do it. So you want to have this rhythm, right? Notice when you walk, you have a rhythm. In a lot of things that you do as a human, you follow this rhythm. And when you keep this rhythm, it becomes a lot more easier. So use the tools continuously. There are things you could do like using cruise control, continuous integration tools, and so on, that can be extremely helpful. So to conclude, these tools can help you to be more productive, to be more agile. But what you want to do is to use that to the right measure. You cannot go overboard with it. Also remember, the tool is not going to solve the problem for you. Good people who prudently use the tool are going to solve the problems for you. And that is something, given a choice between advanced tools and poor developers, poor quality developers, and given a choice of average tools but exceptional developers, I would much rather have exceptional developers with mediocre tools, because then they create tools they need, they become craftsmen, otherwise they stay as workers. So hopefully this gives you, I've merely still scratched the surface of this, but hopefully this gives you an idea of the potential or the capabilities of these things. So any final questions or comments before we say we are done?
Hi. I have a question.
Where are you? Oh, I'm sorry, yes. Oh, by the way, just as a quick note, the 3 people who helped me won a copy of my book, so please do come and get it from me.
Do you know any tool to find out orphan code? Any tool to find out orphan code that is never getting called?
The code that's not being used at all? The question is, I have a tool that's the code that's not all being used, is there a tool to find it? Code coverage tells you that code has never been touched, right? So if you run all the tests and it is never used, you can do it. But with a little bit of a political understanding, this becomes really funny. There's a tool called Ashcroft, right? And this tool actually looks for code that's never being used and gets rid of it, right? So there's a tool for that too. Other questions or comments? Yes? So there's JS unit. Yeah, JavaScript, JS, unit. There are tools available. For almost every language, there are tools available. Yeah, you can do that. Other questions? All right, that's all I have. Thank you.